Hello everyone. Before I get started, I want to mention that I am going to cover many slides very quickly today. At the end, I have some potential resources for you and my contact information is there. If you want to copy a slide, you can just reach out to me. I'll be happy to send them to you. My talk today is about software developer maturity and growth. I've been in this industry for over 30 years now, and if you've been doing anything for a really long time, you start to realize how valuable cumulative experience is and how much you lean on that, especially if you start working with younger people in your community, in your company, or in your community. This longevity of experience often puts you in a position to reflect about what you've learned over these years, and there are some patterns you might see as industry changes. Most people in the software industry today probably went to college and majored in software engineering, or they have a degree in computer science or data science or software development. But surprisingly, I am not one of those people. My undergraduate education is in electrical engineering, and I thought I would share this little gem with you. This is one of my actual textbooks, which I pulled out of a box in my basement. It is the only programming class I was taught in college. That is it. So I am one of those people who has had to learn this field all on my own. I used to think that this was a considerable liability, and for a while it was a real liability because I was missing a lot of knowledge and information that would have been useful. But over time, I started to realize that this was really an advantage for me personally. A couple reasons for this. I needed to fully understand the gaps in my knowledge and skills, and then try to figure out what the resources were that I could use to try to fill those gaps. I actively immersed myself in this learning process. I also had the advantage to be able to work in organizations where I could apply what I learned. I know this experience is not available to everyone, but once I had the chance to put what I was learning together with my other experiences in engineering, I started to really understand the breadth and depth of software development and how it should be treated as a software engineering discipline. I helped start a company about 12 years ago called Don't Panic Labs. And when we started that company, we knew that we wanted to build a culture that had a strong desire to practice software development as an engineering discipline. It became a great laboratory for us to really put these things into practice and really try to grow and evolve this and really see what it looked like. As a result, the people that worked in that organization have a path to growth that has really been defined by how well they grasp what we're trying to do. So all of this is a little background today for what I want to talk about today. First, I'm going to try to characterize or illustrate what I've observed as the stages of developer maturation. And again, this is primarily from my own experience. Then I want to combine that with some reflection or some ideas about what the path to growing through those stages might look like and where people should focus. Now, when I started thinking about this, how people grow and mature in the industry, my brain leapt right to those people that I've worked with over the last 30 years that were at the pinnacle of their profession. What were the things that really stood out about those people? What stands out to me first and foremost is that they learn profoundly from their experiences. They don't just kind of realize that they're learning things as they go, but they actually are active about trying to leverage that. You know, we often talk about how much pain we suffer in software. Well, they don't just endure that pain. They look for ways to overcome that, to prevent that from happening. When we are younger, we tend to gravitate to the more clever or esoteric solutions to problems, or try to use fringe technologies. But as people mature, they realize, hey, you know what? If I find a simpler solution now, it's probably going to pay off in the long run. There are no bonus points for being clever. We have an expression at Don't Panic Labs where we see someone has the ability to see around corners. This is the ability to anticipate things not just as they are, but to see where things might be going, and to build that into their decision-making and trade-offs that they're doing. Mature engineers recognize that trade-offs are the norm and absolutes are rare. Generally in life, when you're younger, you tend to think that things are pretty much black and white, or yes or no, right or wrong. As time passes, though, you start to realize the world is really more shades of gray. And that's very true in every field of engineering, which means we're constantly making a trade-off between two potentially desirable outcomes. And that becomes the norm of what we're doing. People at the top of their profession invest in themselves. They recognize the limits of their knowledge, and they're very active about trying to overcome those limits. As a result of that, their skills and knowledge tend to transcend the technologies and the frameworks or even the programming language that they're using. And this skill makes them way more valuable. They understand the importance of repeatable processes that create successful results. They are really more focused on how we're doing things and not necessarily the what and the what with. They also know when you start to pursue a software engineering mindset, it's important to be disciplined and structured. You want to have strong beliefs and strong ideas about how to do things, but you don't want to get so dogmatic that you're not open to new ideas of how things should be done. People at the top in this profession understand the importance of process and discipline, but they won't let ineffective processes get in the way. You don't want to just adopt things because you read about it in a book and then think that must be the way to do it, right? We don't want to blindly adopt a cargo culture, if you will. We want to make sure we're discerning and try out new processes or techniques that may help solve some problems, and then discard those things that really are not working or providing guidance. We want to be as lean as possible. They are obsessed with quality. The first thing I think about when I think of the best developers I've ever worked with is not how skilled they were as programmers, but actually how good they were as testers. The way they planned testing, the rigor to which they designed and tested their code. I tell young developers all the time, if you really want to differentiate yourself from the rest of your peers, get really good at testing and be the person that everybody looks to who creates and tests their code better than anyone else. They also understand that it's not just about programming. It's about the design and how we maintain these systems over time. We don't just build version 1, throw it out there, and move on to the next project. Any software that's really worth anything evolves over time. And the only way that we can be effective is to invest in good design. And then when a decision needs to be made in the heat of the moment, when they may need to do something, this may be particularly true when we're working on hotfixes, successful people take a step back and are a little bit more strategic at this point. And they might need to think about returning to the idea of making some trade-offs. It's not just about being responsive and getting a solution to this immediate customer problem. It's important that we avoid these little quick workarounds and little poor decisions that tend to erode our systems over time. And finally, they understand that software is a team sport. And just like any other team, it's not enough to just have good players. You also need strong leadership. You have to have somebody there who's keeping us all together, making sure that we're all following the same playbook and running the same play. And we don't have any weaknesses within our team. So that's a summary of what I've seen makes a truly great developer. If you aspire to try to be one of them one day, what does that path look like? What should we be doing, or how should we be approaching it? Well, to start with, we need to build a framework for this that allows us to answer the question, how do we evaluate these developers that I'm talking about, and what should they be learning? Let's start thinking about this in terms of software engineering and not just programming or software development. I'm sure you've heard that before. We tend to throw this word around a lot, software engineering. But in order for us to dig into this, we really need to understand, what does software engineering really mean? Let's make sure we have a shared definition of what that is. And also, let's talk a little bit about what the end game will look like when we're actually treating software development as an engineering discipline. What should we expect? And then finally, we need a knowledge and skills map so that we can be rigorous about evaluating people. I think this is the best definition for software engineering. It comes from IEEE, which is, of course, a trustworthy source. They've invested a lot of time and energy into trying to define it, so I'll just read it to you. It is the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. In other words, the application of engineering to software. One thing I like about this, if you look at the definition of other engineering disciplines, they look very similar, short and to the point. It contains the word systematic. This means we have a method. We have a system for how we develop software. Discipline means we're following that method. We're consistent in the way we do things. We're not just randomly choosing approaches. And then quantifiable, which means we have some sort of way of measuring how we're doing. We have a feedback loop and can improve things. So the next thing is, what will it look like when we are practicing software development as an engineering discipline? Well, first, I will tell you what it won't look like. Over the last 20 years, I've observed that the success of many software projects relied very heavily on what I call a virtuoso performance by a handful of developers. These are the developers that have enough tacit knowledge and skill that they are able to carry the project over the goal line despite the fact that the rest of the team was not contributing in a useful way and might even be holding them back. For some of us, the project feels like a death march where we are working 60 or 70 or 80 hours a week to try to get things going. Now, we could try to continue down this path of what we did before, but here's the challenge. The types of problems we're trying to solve today, they are orders of magnitude more complex than the problems we were solving in the past. I worked with a team that built an e-commerce platform. This was two decades ago. And at the time, it was really hard work. We had some commercial success with that, but I look at that now, and our efforts look almost naive in terms of what e-commerce looks like today. One of the companies we launched in the last 10 years builds computer vision applications for athletic performance in healthcare. 10 years ago, if you told me that we were going to be building computer vision applications with a small group of people in Lincoln, Nebraska, I would have thought, that's way out of our league. We would not be able to do that. So software is everywhere. I don't need to tell you that. And the complexity of the problems we are trying to solve with software will continue to grow. What the future could look like, and probably should look like, is to have this body of knowledge, this shared understanding of what is software engineering and what does it mean. And then when we all understand this becomes our guide for how we approach things. Think about if I hire a bunch of civil engineering firms to design a bridge over the Missouri River. Do you think they're all going to be radically different in their approaches? Would they apply a random or completely different set of rules to each design? No. The bridges are going to look a little different. They might use some techniques that have worked for them in the past, but they're all working from the same principles, and they are guided by those same principles. So with that, the solutions to our problems that we are dealing with should be shared, should be things that we can reuse over time. This is something we're actually seeing today. 10 years ago, the cloud was all about hosting applications. But since then, other services in the cloud became available for us to use, whether it's authentication services or machine learning services. These are hard problems to solve, but they are common problems. And we can save time and use those services to build our own applications. I think we're seeing this more and more today. Using these first two bullets, software developers with average amounts of experience should be able to tackle many problems with consistency and do it routinely and predictably and have success. Much like if I go to a civil engineering firm and say I want to design an overpass, they're going to do it and be successful. That's what you want. You want that predictable outcome. And then for some novel things that are exceptionally challenging, like building cloud services or designing an autonomous re-entry system for a Mars rover, maybe that's where our virtuoso performances really should be focused. For most of us, it's unlikely we're going to be involved in solving those types of exceptionally challenging problems. The vast majority of us should be able to manage and predictably solve the problems we are working on. With very few exceptions in my 30-plus years, I've never doubted we could find a solution to the problem in any of the projects we have worked on. I think for the most part, the likelihood of finding a solution is deterministic. And it's those rare challenges that maybe require virtuoso performance and that innovative or novel approach. All right. So the third thing we need is this knowledge and skills map. And I want to go back to IEEE again. Maybe some of you have heard of this, but I suspect many of you have never seen it before. And that is the Guide to the Software Engineering Body of Knowledge, which is now in its third version. This is something that has been developed by IEEE over the years, and it is common for a lot of other engineering fields. So you can go out there and find the systems engineering body of knowledge and the electrical engineering body of knowledge. This notion of a body of knowledge is very common, especially within academia, but also in much of industry as well. There exists a collection of what is known about software engineering, and this book is your guide to that. The SWEBOC, for short, has some specific objectives of what they're trying to do. They want to make sure that we have a common view throughout the world of what software engineering is. They want to characterize and describe the contents of that body of knowledge. Now, to be clear, this does not contain the body of knowledge, it's the guide to the body of knowledge. What they're trying to do is provide you access to those authoritative resources that really contain the body of knowledge for software engineers. And then finally, they want us to use this to create curriculum. The University of Nebraska now offers a software engineering degree, and it's one of the few software engineering degrees in the country, believe it or not. Most people coming into this industry are still getting a computer science degree, which is kind of like getting a physics degree and then deciding to be an engineer. Going forward, we should see more undergraduate software engineering programs that are designed and built around resources like SWEBOC. The SWEBOC actually contains 15 knowledge areas. They try to characterize all of the different aspects of software engineering into these 15 buckets. I'll go through these pretty quickly. Software requirements, software design, software construction, there's testing, maintenance, all the kinds of things that we are used to doing on a daily basis. But then they cover software configuration management and software engineering management, which is kind of project management, and then the software engineering process. This is the software development lifecycle and things like that. They have software engineering models and methods, which is how we structure the models that we use to design systems. Software quality, which is not just how we do quality, but how we measure what quality really means. Software engineering professional practice, which is what it means to be a professional as a software engineer. And then software engineering economics, which is probably a shocker to everyone, but we're part of the business, right? All the decisions we make have an economic impact, so this is an important aspect as well. And then there are 3 foundational areas. It's a bit like table stakes in a poker game to get into the field, but it isn't really directly related to software engineering. However, they are essential bodies of knowledge that we should be aware of. So in other engineering fields, your first 2 years of college, you're taking physics and math and chemistry. You're not taking any engineering classes. You're taking classes in these foundational areas. So one of these is computer science. That's the whole body of knowledge in and of itself. And then mathematical foundations, specifically things like logic and reasoning and discrete math. And then engineering foundations, some of those common patterns and principles that transcend engineering fields. All right. So I have 15 knowledge areas, but that doesn't really help me. I want to group these together to make sense of this. I've come up with 5 separate areas: foundations, management, execution, structure, and then professionalism. I laid out these knowledge areas within these various areas to try to build a map that I can use to evaluate the maturity and growth of developers. Since we are mostly talking about developers, I'm not going to focus much on the management side. It's part of the body of knowledge, but it's these other things I'm really focused on. All right, how am I actually going to do this? How will I define these growth phases and their focus? Well, I'm not going to do it by height. We will leave that to the folks on Caddyshack. What I did is I came up with some personas. These personas really reflect the personas within my own organization based upon my experience. And your mileage may vary, it may not resonate with you, but it's kind of what I know, and I'm really just trying to illustrate a process, if you will, and a potential model for you to think about. And I recognize that maturation of any skills and knowledge is not a set of discrete transitions from one state to another. It's a continuum, right? So it's a little bit artificial, but I think that it might help to make my point or give you some things to think about. I have 4 personas that I'm going to describe here. First, I'm going to talk about what their skill level is, and then what their blind spots are, which I think is very important when we talk about growth. What are they not good at? What are some of the things that might really differentiate those people that are considered to be high performers within that particular level? And then we look at areas we have tried to focus on as these developers are growing, the target area of our focus. So the first persona is the entry-level developer. These are the people that are either self-taught or they might have gone to a code school or got a college education. They probably have some generic programming experience from a few academic assignments or maybe cultivated from some internships, hopefully. They can probably build some websites with a light back end and are probably familiar with some development environments. They probably have been exposed to some agile methods, given that's pretty pervasive now. They do have some skills, but they have some blind spots as well. Most don't have a lot of experience in developing actual applications unless they've actually worked in an internship. Another common blind spot that we talk about a lot is this notion of errors in judgment. When I talk to students coming out of college and see them working on a problem, they have a lot of knowledge, but oftentimes they don't see around corners, if you will. So they make errors in judgment. Nobody is maliciously making mistakes when they are coding, but it's these things that really cause problems over time, people just making mistakes. They also don't have much design or testing experience, and probably the biggest thing is their gap in foundational knowledge in computer science, mathematics, and engineering. A very important thing that will differentiate folks in this category from others is a lot of internship experience. Students that have been through internships have a better perspective on what it really means to develop software. Top performers are also pretty motivated to grow and understand and learn, and the ones that are the best at that are the ones that aren't afraid to ask for help. This is so common for many people coming into the industry, especially coming right out of school. They feel like they can't ask questions, like it makes them look weak or like they don't know what they're doing. Well, here's news for you. None of us really know everything, right? No one has the tiger by the tail. All of us have to ask questions, whether it's to Stack Overflow or the person next to me. So where I think these people need to focus is, let's not just jump right into, hey, I'm going to be a great coder. Let's take a step back and make sure that we're really understanding this body of knowledge from computer science and to some extent the mathematics. I think it's absolutely critical that you get that foundation. Maybe it doesn't have to all happen at once, but that should be part of what we're trying to do if this is you. Then the next thing would be, I want to go into the software design and testing, because those are things that people tend to be the weakest in. They tend to understand the syntax and the structure of programming, but they tend to not really understand what it means to do design or how to test. And finally, start exposing yourself to some of the concepts and software requirements and engineering models and methods. Start building a working knowledge of these areas so you have more context for understanding other roles in your team. So this is what the entry-level developers look like in the map. This represents that they have some experience with software requirements and some experience with construction. Everything else is kind of a blank slate at this point, right? We really want to increase focus here in foundations and start building knowledge and expertise in design, testing, requirements, and modeling, as I show with the red boxes. So here's the second persona, the experienced developer. You've got some miles on the tire now, you've had some experience. They typically have good programming skills across a lot of different technologies. They know how to program, they're good at that. Some of the analytical, critical thinking skills are emerging at this point as well. And they are starting to understand what it means to be a professional in this organization and the ethics around that. And if they are in the right organization, they are probably starting to see and understand the importance of some of these management processes and models and methods. And they probably have been providing support, so they've got some experience in maintenance. They can follow the patterns you've used in the organization over the years, but the problem is they might not be able to explain why they're doing it. They may not fully understand the underlying reasoning behind the patterns, but that's okay, they're learning. Errors in judgment, still a problem with this group, so that's not going to go away anytime soon. And then understanding what makes a good designer bad. This is a very difficult thing for a lot of people to understand, because we live in the world of gray decisions where we are not certain of the long-term consequences. The top performers here have a quality we like to call humble confidence. You want people to have the confidence to go out there and tackle things, but you don't want them to feel like they are so confident that they don't need help from anybody, right? Ideally, they have just enough imposter syndrome to get feedback and validation on things. These developers are also starting to be very organized and deliberate about their learning. They seek out what they need to learn or what resources they need to grow, and this is an important differentiator. They start to really care about the quality of the testing. It's not just about fingers on keyboard and coding. So again, software design and testing, it's so important. And it's such a weakness in a lot of these more junior people, they forget the fact that they have to do that. But we can also layer in thinking about the structural knowledge areas. How do we actually architect things? What are our methods for doing that? What are the things we do in our software development process to help create these predictable outcomes? The experienced developer map is starting to look quite a bit different from the entry level. They're getting a lot of construction experience. A lot of their doing is coding, right? So they're getting a lot of experience there. But now they have at least some working knowledge of a lot of these different areas. And maybe even over here in the structure area where we're starting to fill this out nicely. But again, I want to really focus on these areas highlighted by the red boxes, the software testing, design, and models and methods. The third persona is the emerging leader. These folks are really starting to get it. They're starting to see what they're trying to do and advocate for best practices. They're stepping up to make sure that people are not cutting corners because now they follow the process and they've seen it work. Emerging leaders start to really understand the need for application of a systematic, disciplined, quantifiable approach to software. They probably lived through some bad experiences at this point and realized we want to follow the path, we want to be disciplined. And this one is interesting. They start to be empathetic and advocate more for the customer. Emerging leaders can effectively apply patterns and best practices not only in their own work, but they can coach others during code reviews. And now you start to see the errors in judgment decrease. They're making good, solid judgments in that world of gray that they live in. Testing expertise and design expertise are still emerging. This is a skill where you can't just read a book and you're going to be good at it. You have to do it. You have to practice. You have to get feedback over time, but they're getting there. When emerging leaders get to this level, they have some confidence. They have some credibility. Problems come in and they're saying, all right, I can solve this problem. They can sometimes be a little too focused on being responsive when they really should take a step back and be a little more strategic. We've all seen something like this where we hurry to push a hotfix out there only to find out that it broke something for some other customer. They need to be that person that has the judgment to say, whoa, and pump the brakes when needed. Top performers are starting to be able to coach others. They care deeply about software design, even if they're not quite able to do it on their own consistently. They're getting better at effective testing, and they're starting to seek out mentors to help them on their journey. And now we can focus more on the structure side, the models, methods, and engineering processes. They got everything else in the middle, and this is what their map looks like. And this is where we want them to focus. The last one is the software engineer. They can consistently get successful outcomes on a project regardless of the complexity. They recognize when things are ill-defined or when we don't have a necessary process and we're leaving things to chance that could cause problems down the road. They're always looking for ways to not just follow the process, but to improve it. You know, what are the techniques that could be used to solve the problem or plug that gap in our process? And then they start to think about how we're engineering the software. We're not just developing the software. In terms of their blind spots, they tend to be the things outside of software engineering. When they get to this point, they want to start thinking about how other engineering disciplines solve problems. They should start learning about what systems engineering is and how it can help us be more effective. They should start to be responsible for getting us to the point where we are practicing software as an engineering discipline. The top performers here, they're the ones that can help guide and define the process, the way we're doing things. They often have the ability to teach as well as do. Those people tend to be the most valuable ones. As far as suggested areas of focus, I would go completely outside of the software engineering body of knowledge. Start looking at other things going on. Start understanding what engineering really means. Learn more about systems engineering. The software engineer has a working knowledge that covers a broad area of this map. So what should I take from this? How do I use this? Well, one, I think it's valuable, if you're not doing it already, to do the self-assessment. Use what I've talked about as a starting point, or maybe modify this and evaluate where you think you stand. And be honest about it. If you are weak in some areas, it's okay. It just highlights areas where you want to focus. And then be deliberate about tackling those areas and tracking your journey so that you can create a path forward. Some of the best developers I've ever worked with were very deliberate about this. They had a path. I will focus on this and this and this. Personally, I have stacks of books that I just continue to accumulate and read and reference and try to understand. It's a journey, not a destination. And in case you're curious, this is my skills. I try to take an honest look at myself. This is where I feel that I am right now. It might surprise you that my software construction skills are maybe a little light. I often tell people that I'm the worst programmer at Don't Panic Labs. If you're relying on me to get a thing done, I would be relearning some of the language constructs every time I get in the code. But there are other areas where I feel like I have strengths, like my background in engineering. I was a systems engineer for the first 7 years of my career. So this map is where I'm at, and I'm continuously trying to fill the gaps. After more than 20 years of intense focus, I still feel a weakness in areas, but I can rely on people from our organization and other people who have a solid educational background in computer science to really help me along. So if you aspire to continue to mature and grow in this field, you should recognize that the traditional education systems alone are not going to get you there. They're a starting point. When I was in college, one of my professors was talking to my classmate who was complaining that he'd never be able to memorize all the steps to solve the complex problem we were working on. And what that professor said stuck with me. He said, "I'm not trying to teach you to memorize this. I want you to learn where to go to find the answers. I want you to know that solutions to this problem exist, but it's up to you to seek them out when you need that information." You're also not going to be able to get all the experience you will ever need in your current role. So if you're just relying on on-the-job experience, it's probably not going to be enough by itself. It might even stunt your growth. That's not to say you can't ever get there, but it will slow you down. Being the best programmer does not make you an engineer either. Sometimes I feel like we really focus too much on things like, do I understand this framework, or can I use that framework, to the neglect of all those other areas of the software engineering body of knowledge. If you recall, when I was talking earlier about the best developers that I ever worked with, not once did I mention that they were highly skilled programmers. This is because I think most people who spend time in this industry do become highly skilled programmers, but that's just one aspect of being a great engineer. Your progress on this path will be dictated by your efforts and, to be brutally honest, where you choose to work. Some organizations are really devoted to trying to grow and improve the way we're doing things. I'm currently working with a large company in Omaha that is devoting substantial resources to try to level up their development staff and help them gain a broader understanding of software engineering. That's incredible. I just don't see that everywhere. So every organization is a little bit different, and I'm not telling you to leave your job, but I think you should recognize that where you work could be a strength, but it might also be a weakness. Maybe you can advocate for change in your own workplace if you feel more could or should be done. One thing that organizations can do to help people advance and grow is to have a system in place for software development that enables the developers to put their learning into practice. I'm not simply talking about some agile methodology. I'm talking about a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software that covers both requirements complexity and solution complexity. The last thing I want to leave you is a simple takeaway in the form of a couple of recommendations. I highly recommend that you try to identify mentors, and I put this in quotes because you can define mentors however you want, but find some resources that can help provide guidance and coaching that might point you in the right direction, or maybe help you evaluate yourself where you're at right now. And then leverage the abundance of resources that are out there to help you with your gaps. I'm going to go over some of these here to end the talk. If you're looking for an index to software engineering, that point where you're saying, I want to learn about this, where do I go? That's really what the guide to the software engineering body of knowledge is. But I would also throw in another book. If I had to choose only one book, I could only have one on my shelf. This is the book I'd get, Code Complete. Steve McConnell has attempted to try to bring together much of the software development body of knowledge in one place. It's an incredible reference that I've used often and for a variety of topics. As a result, you're going to see it often on the list I'm sharing here. Concerning software design, this is an eclectic group of books. Some of these are very detailed patterns books like Design Patterns. Some of them are more architectural, like Building Evolutionary Architectures by Neil Ford or Writing Software by Yuval Lowy. Code Complete, again, not really about architecture, but does talk a lot about detailed design. Then you have Robert Martin's book on Agile Principles, Patterns, and Practices. Then you have this book here by a faculty member out of Stanford, John Usserhut, A Philosophy of Software Design. It's only about a 100-page book, which is delightful to read, about bringing his industry experience to the classroom and learning from that. And then the book by Fred Brooks Jr., The Design of Design. This is a series of essays on the nature of design, which I thought was fabulous. Software testing. There are a lot of books on software testing. This is where I would start. In Code Complete, he devotes numerous chapters on defect detection and testing, in which he boils things down for you in a way that will get you started, and you can put some really good techniques and principles into practice. Models and methods. When it comes to software engineering models and methods, I'll be honest, I don't have very many great references here. I have Yuval Lowy's excellent book, Writing Software, and then Von Vernon's Implementing Domain-Driven Design. They are the only two that I'm familiar with that are prescriptive enough to get you to understand the concepts and then put them into practice. An average engineer should be able to take this and put it into practice, but too many books leave things out at a high level and don't really give you a tool set. Computer Science Fundamentals. I'm going to throw these up here because they are super important. I think a lot of us, especially people like me, come into this from other backgrounds and are weak here. And there's a number of resources that can help. Once again, the Code Complete, and this book by Charles Petzold, Code, The Hidden Language of Computer Hardware and Software. Petzold used to be the author of the most popular book on the Win32 API. This was a really nice, great look at how computers work in the hardware side, and it was just super fun to read. I really highly recommend that book. Then we have Rob Connery. He actually went about trying to write a book specifically for people like me who are self-taught, and he called it The Imposter's Handbook, which I thought was a great title. He fully admits he's trying to learn computer science fundamentals, and he expressed the concepts in a way that was very approachable. Finally, here are some other interesting, useful resources that I think are great books. The Problem with Software is helpful if you really want to understand how we got to where we're at in software development. Adam Bard does a great job, and it is a great read, especially for people in my generation who were around in the 80s when the PC revolution was happening. Making Software is actually a collection of rigorous research studies that apply to what we do today. They are studies of organizations like us, and it shares what the data tells us in terms of what things work and what things don't. Lean Software Systems Engineering for Developers is the book that Chad Michael and I worked on during the pandemic, where we put some of our thoughts in place. And Capers-Jones' book, Applied Software Measurement, has a ton of quantifiable data about how things work in software. This brings me to the end. Thank you. I appreciate the opportunity to come and talk to everybody. I hope you found something you can take away from it. If you want any of the slides, here's how you can reach me. I'd like to leave you with one of my favorite quotes by Gerald Weinberg, who's pretty famous in the field of computer science. He actually grew up in Nebraska, just outside of Lincoln. Thank you.